We have the second set of presentation. The first speaker is Edurne Uranga. She's an industrial engineer, support engineer in the collective transport agency of the region of Madrid. She's in charge of facilities that are developed within the context of the expansion of the Madrid network. And before, she held a number of positions in the industry and energy agencies of Castilla y León, where she was responsible for power plant, for the construction of power plant within the renewable energy field. So her presentation is the thermal activation of the expansion of line 11 of the subway in Madrid as a source of geothermal energy. Hello, good morning, everyone.
Gracias por invitarme a este foro.
Firstly, thank you very much for inviting me here. This is a forum that we need. Thank you very much to Madrid Subterra, to the University of Madrid, to Metro Madrid. Well, I'm going to be talking about everything that the Transport Infrastructure Agency of Madrid is doing, which I think is quite interesting, especially in aspects relating to optimizing geothermal energy in Madrid. I wanted to give you the background of thermal activation here in the Metro of Madrid. First of all, actually, I'm going to introduce my agency, which is responsible for the implementation of expansion works in the subway of Madrid. And Metro Madrid is the actual the one that is the runner, the one that runs the actual subway. So when I talk about Metro, and when I talk about my agency, I'm talking about two different things. That's basically why I wanted to clarify that. So Metro Madrid in 2009 launched a project aimed at the thermal activation building collection wells in the Pacific Metro station, which is in line 1 of the subway of Madrid. This was a project aimed at heating the platforms and some of the businesses that are in the subway station. This thermal activation system had the challenge that it was using capturing wells that on a constant basis received heat from the geothermal system of the station. In other words, we're talking about a low enthalpy installation. Oh, my apologies. Low enthalpy installation, where we had those wells that were used to exchange temperature that was then taken to a geothermal pump. The problem with this pump is that demand of the station was not balanced. The demand of the subway didn't only demanded cooling. So that's why we always had, the entire terrain around the world was just heating up constantly. And as a result, the lifespan of those wells was not as high as we expected. And that meant that the surrounding area heated up. So here there was heat storage that now we're trying to extract, to withdraw to the outside. And as in line with the previous presentation, what we're trying to do is to make sure that district heating can be evolved so that we can collect all the heating that is stored in some of these wells in Madrid, in the Metro of Madrid. I'm going to talk to you now about some of the actions that we expect to undertake within the responsibility of my agency. These are very important actions and initiatives, and that somehow speak volumes about the potential of a geothermal generation as a source for cooling and heating in the subway. For example, we have line 5 which will be expanded from Avenida Osuna until the airport. We have line 11. All these actions within line 11 is related to a bigger infrastructure that is going to be developed in Madrid that is going to connect the north and the south, and it's going to allow us to connect the entire community. So we're talking Cuatro Vientos de la Fortuna, Plaza Elíptica, Conde de Casal. This is the action that I'm going to be focusing on during this presentation, because it's what we expect to implement a geothermal system. Then the section from Conde de Casal to Mar de Cristal, the section from Conde de Casal to Mar de Cristal, which is going to be divided into two different sections, because it's quite large, quite long. And then we have Mar de Cristal, Valdebebas. All this investment in all these initiatives are of a public nature, with the exception of Chamartín Forcarral Norte, which will be funded by a public-private partnership. In the latter, we also expect to include the installation of geothermal systems in addition to other power generation sources, renewable, obviously. And then also in the subway station, we'll have the exchangers. The good thing about these initiatives is that we will install equipment that can be used to exchange heat, and then above ground we will install some facilities that will collect that energy and that will make the most of it. In this case, the exchanger of Conde Casal is interconnected with the action of Plaza Elíptica Conde Casal, because in the same station on line 11, in the same place, at the surface, we will have that exchanger, which will be the one that will collect the energy that is generated in each, as I was saying, of the areas of the metro. We're going to thermoactivate the different structures that are collected in the subway stations of Madrid. So we collect the residual heat that is latent in the subway of Madrid, and we will return it as usable energy to the exchanger of Conde Casal. That's the idea. We'll have additional initiatives, such as the exchanger of Valdebebas and the one Legazpi, and another one in Chamartín. As you can see, these are very important projects. It's a significant investment within the region of Madrid, and therefore this will be a great opportunity to use renewable energies and to kind of change the way things have been done so far. This is what I said before, which is the connection between north and south, from Cuatro Vientos to Valdebebas. As I said before, these are the different sections of line 11, kind of like a graphic representation.
Here you can see, as part of the actions for the Diagonal in Madrid, all the hubs that will be created. So a hub in Plaza Elíptica, a transport hub in Cuatro Vientos, in Atocha, Mar de Cristal, Conde de Casal, Valdebebas, the airport, and Chamartín. It's important for you to see what's going to be executed on the surface and what it connects with, so that you can look at the potential people and companies requiring heat and heat from this metro. So here we can see in yellow what we're going to do from Plaza Elíptica to Conde Casal, the bit that we're going to talk about in this speech. And we're going to talk about what we're going to execute immediately. So all the other actions will take longer. This will be the most imminent one. And here you can see more detailed. In this slide, we present why we decide to execute this section. This section is being done because of the demand. There's a demand across this area, and it's something that was required. So we are creating two new stations, Comillas and Madrid Rio, and we are interconnecting this line to other lines in Madrid Underground. Plaza Elíptica with line 6, Palos de la Frontera with line 3, Atocha with line 1, with the commuter trains and long distance trains, and Conde de Casal with line 6. Conde de Casal station, we're doing the underground but also the surface work for the transport hub in Conde de Casal. And well, here you can see the amounts that will be invested. So let's talk about the Conde de Casal underground station. This is the station that we aim to use as a project for Metro de Madrid and for the Infrastructures Directorate. Is going to be pioneer for the thermal activation of the structures. We want to carry out in this station is, as I said before, briefly, where we want to thermal activate the infrastructures, both at the station, but also in the tunnels, in order to exchange the surplus energy that we have. Obviously, when the trains break, they produce heat. All the facilities, in fact, produce heat, which is a problem for us and that we must eliminate. So we are thinking of thermal activating the structures so that we can give heating and cooling to the Conde de Casal transport hub. Just so that you can get an idea, normally the stations, you can see how it is in the plan. Conde de Casal train station, we have the project already designed. And what we aim to thermal activate are the screens and the pillars within the station. So this is the station, as you can see it in a cross-sectional map. The thermal activation will be done on the screens and on the pillars. On the shafts. So just like we did with the section on line 11, we're going to do the same with the Conde de Casal transport hub. Here you can see the investments that we're going to make. The Conde de Casal transport hub is subsidized with recovery and resilience funds, and this transport hub will be done in such a way that all the energy required for its operation will come from renewable sources, not just from geothermal energy, but also from other renewable energy sources. It's also important to talk about how we built it. The line 11 section that's going to be executed will have two different construction methods. The traditional Madrid method for 679 meters, and with tunneling machines 5,593 meters. This gives you an idea of the size and dimensions of this project. Here I describe the traditional method for Madrid so that you can see how we execute it. You can use this QR code if you would like to watch a video, and that will send you to a YouTube video where you can see how we execute those 679 meters of Madrid. It's also important to say that this method that we are executing, it's important so that you can see the way in which we are going to put the pipes for the geothermal capturing. So they'll be including, well, in this case, they will be on on site, on the keystones, on the piping, but on the TBM, the tunneling method, which is a total of 5,592 meters. In this, for this construction, they will be prefabbed with their pipes. In subsequent slides, you will see how the tubes, the pipes are inside the structure. You'll see that in just a minute. So this is the section for the tunnel. Typical for the tunnels in Madrid. And this is so that you can see the piston factory needed in order to execute it properly. As for the station, the construction will be different. Is cut and cover. What we actually normally do is the cover, the top screen of the station. Once we've done the top cover, then we start to carry out the inside of the station. So we'll thermo-activate the screens that are already in the station. The thermo-activation project, as I mentioned, is going to give cooling and heating to the transport hub. This geothermal system initially aimed to provide 30% of the heating and cooling services through the geothermal substations, and also it will provide hot water with the system. The idea to execute this project is, as I said before, the thermal activation of the structures, but also we'll have capturing wells. So we'll need these capture wells because we need to eliminate the heat that comes from the underground system, but we also need to somehow store in the summer all that surplus heat. So in the winter, we'll use it, and in the summer, we'll store it because there will not be a heating demand. And that's what I was mentioning before, just so you can see how we do the introduction of the pipes, how we will implement the pipes that will capture the geothermal energy and how we put it into the structure. So here we have a pile where we put a pillar where we put the pipe in, and once we bury it, we'll fill it up then with concrete. And this is where all the pipes will be. Yeah, this is the piping ring, we could say, where we can see the different pipes that come from the different thermal activated structures. On the screen, well, here we have the different screens. It's very similar to underfloor heating. We thermal activate the whole area, then we cover it with concrete. And that's the way to recover that energy. And on the keystones, on the voussoirs, we can do it in different ways. The way in which we execute it it's a new way of doing it. It's not on existing infrastructure. So we're going to use this system where the pipe is embedded in the keystones. If they were already built tunnels, we could have like a heating blanket that could capture the energy. And that is all. I would just like to say that as the General Directorate of Infrastructures, according to the law, we have to carry out infrastructures, build infrastructures, removing the residual heat, and we cannot remove it as we used to do before. In the past, the heat was just sent to the compensation wells and the air just went out to the atmosphere, onto the streets. Now the law forces us to find alternative ways to evacuate that heat and use it, obviously. So the Directorate of Infrastructures has implemented this project. This project will be monitored so that we can have data regarding how much heat can be obtained from the underground infrastructure, because currently we only have theoretical data, we do not have real data. So what we're going to do is to monitor all these installations so that we can actually see how much we can make from Metro de Madrid. And I think this will be a turning point. Thank you very much to all of you.